we will work on a few substitution problems. So let me copy this question. Evaluate the definite integral from 0 to pi over 2 sine of 2t dt. We would like to find the integral sine of 2t dt from 0 to pi over 2. Okay, because we have the limits of integration, this means this is a definite integral. And the result will be some number. Okay, so it's not going to be resulted with a function, but it's going to result with a number. We know that sine of t, or let's say sine of x dx, is negative cosine of x plus c. Okay, so you can find it under the table of integrals or antiderivatives. In this case, we have 2t. So what should we do? So this is in fact composition of functions, and when we have composition of functions, then what we use is we use the substitution method. So we can call 2t as u, and in that case, let's write that down. So if u is 2t, du over dt, it is derivative. The derivative of 2t will simply be 2. So we can say du is 2 times dt. So just cross multiply. Now we need to rewrite our integral in terms of the u variable. Well, we have only dt in this integral. We don't have a 2. So whenever we see dt, we should just replace it with some expression involving u. Therefore, we can divide both sides by 2 to find that expression to plug in instead of dt. So this integral now becomes sine of u du over 2. Okay? Instead of dt, we just plug in du over 2. You can just say this is 1 over 2 sine u du. And whenever we have a coefficient, we can take it out as 1 over 2 integral of sine u du. So that we have the integral of sine, the sine function. And that would be 1 over 2 negative cosine of u, right? So once we find the integral, we get rid of the integral sine and du. So the table of integrals, antiderivatives, would give us that this integral equals negative cosine u. So in fact, there is one thing we didn't copy in the question. This was a definite integral. So we have the limits of integration, 0 to pi over 2. But in fact, when we change to the u variable, these limits, we have to rewrite them. So let's find what these limits will become if t here starts from 0. So if t equals 0, what is u gonna be? U is 2 times t, which is 2 times 0, that is 0. So in fact, this limit will stay as 0. And if t equals pi over 2, the upper limit of integration, then u will become 2 times pi over 2, which is pi. So the upper limit will change to pi. 0 to pi, 0 to pi. Okay, so once you find the integral, you just put these limits using a bar at the end of the function. First evaluate at pi, and then evaluate it at 0 and subtract. So this is going to be 1 over 2. I will just evaluate the function at pi, evaluate it at 0, and then subtract, okay? So what is the function? It is negative cosine of pi. And the function is negative cosine of 0. So you can use the calculator to find these values, but I will just remind you how to find these values. Let's find this value. I will show it here. So this is the unit circle, and 0 is this angle, which corresponds to the positive direction of the x-axis, and pi is this angle. So we just make half rotation. So because this is the unit circle, the coordinates of this intersection point will be x equals 1, y equals 0, and this point will be x equals negative 1, y equals 0. And in fact, these coordinates give us, well, the x coordinates give us the cosine of those angles. So in this case, this is cosine of pi, this is cosine of 0. And the y coordinates give us the sine values of these angles. So what is cosine of pi? So we found cosine of pi would be negative 1, the first coordinate. So this is negative of negative 1, and this is just negative 1. I mean, cosine of 0 is 1, so this is negative 1. So there are a couple of negatives. Let's write this down. So we said that this is negative of negative 1, which is positive 1, minus negative 1. Well, that's also going to turn out to be positive 1. So just be careful with the minuses and pluses. This is positive 1, so there's a negative in front. It is negative 1, but because there's another negative, that's going to be positive 1. So this is 1 over 2 times 2, which is 1. Okay, well, whenever you have sines and cosines, because the derivative of sine is cosine and the derivative of cosine is negative sine, you would call one of them as u. And in this case, because sine is squared, so in problem 10, we should call sine of x as u. Okay, so in fact, we have sine s squared times cosine s ds, and there is some coefficient in front. So if you call sine of s as u, then du over ds, the derivative with respect to s, would be cosine of s. Okay, it is not negative, just the derivative of sine is positive, cosine of s. So we can say du equals cosine s ds. Well, this is exactly the same expression we see inside this integral. So this integral can be written as 9 times, this is sine s squared, which is u squared. We can substitute with u. Then cosine s ds can be replaced with du. So again, just take out the 9 from outside the integral, u squared du. And since, I mean, this is just the power rule, this is going to be u cubed over 3. So this is an indefinite integral because there are no limits of integration. So we don't need to plug in any number, but we should put the constant of integration. And in fact, this 9 over 3 will simplify to 3u cubed plus c. The answer key just shows it as 9 over 3 sine s cubed plus c, but the way, let me just write it the way we found. So it simplifies to 3 sine s plus c. So let's submit it. Okay, so in fact, you can type it this way, or you can say sine of s, and you can cube it. So let's do one last question on substitution, secant of 2x, tangent of 2x, dx. Well, in fact, it is not difficult. It just tells you what substitution to do, to make. So just call 2x as u. Then we can say du over dx. So it is derivative would be 2. And du equals 2 times dx. Well, in fact, we should isolate dx because this is what we see in the expression. So we can say du over 2 equals dx. Just divide both sides by 2. Okay, so now this integral will become secant of u times tangent of u and times du over 2. Instead of dx, we have du over 2. So let's take this out of the way. Whenever we have constants inside the integral, we should move them, carry them out. And now, does this integral seem familiar to you? If you just open the textbook, at the end, you will see the table of integrals, table of derivatives. Let's go to the table of contents, and Appendix A is table of integrals. So here, if you just go down until to 9, secant u tangent u is, its integral is secant u. Okay. So this is 1 over 2 secant u plus c. This was another indefinite integral. We don't need to plug in the values. And the only thing is we should plug back in the expression for u, which is 2x. So this will be the answer. How should we find this integral? You can check out the table of integrals and you will see, in fact, it is the third integral here. Whenever you have e to the u du, it is integral is itself e to the u plus c. But in this case, we have e to the 3t. We should call this exponent 3t as u. Then du over dt would be 3. So du equals 3 dt and du over 3 equals dt. So we will just make this substitution. The integral will be equal to e to the u du over 3. Again, take this 1 over 3 outside the integral. So we have e to the u du. And the table of integrals, if you check it out again, the integral of e to the u du was itself. Because the exponential function, its derivative was itself, its integral is also the same thing. So this will be e to the u plus c. Okay, and the last thing again would be to plug back the expression for u, which is 3t. Okay, so this is the final answer.